have been discussing about, or we have been discussing about the ASA tool signature. Okay. If anyone having any query, just send me a message. Okay. Don't speak. I won't be able to listen. We were discussing about ASA tool signature. So in this ASA tool signature, how many components we have? Can anyone tell me in this ASA tool signature, how many components we have? We have 6 angles and 1 radius. We have 6 angles and 1 radius. So what are those angles? First angle is what? You have to remember one line, that is BS, 2 times of ES. And if you remember this, you will be easily able to write any angle pertaining to ASA tool signature system. The first one is, what is first one? Tell me, what is first one? Hmm? Tell me. Back rake angle. Good, Janvi. Back rake angle, and we represent it by alpha B. The second one is side rake angle. We represent it by alpha S. Then end relief angle. We represent it by gamma E. Then side relief angle. We represent it by gamma S. Then end cutting edge angle. We represent it by psi E and side cutting edge angle. We represent it by psi S. And finally, we have nose radius. I have also told you that we can easily remember with respect to which plane and in which plane we are measuring these angles. Can anyone tell me what is that? If I write with respect to and in, so one line you have to remember, and you can easily find out all the planes on which, with respect to which you are measuring these angles and which you are measuring these angles. What was it? Pi r, pi r, pi x, pi y, pi x, pi y, right? And if you want to write for in which plane, you have to just reverse it. That is pi y, pi x, pi y, pi x, pi r, pi r, right? So this was something that we have discussed in the last class, and we have seen in great detail of each and every plane and how each and every angle that we are measuring in any of the given planes, right? So this was something that we were discussing in the last class. I have written it once again. Okay. So now Now I will be drawing something and I will ask you a few questions and you have to answer. Okay, so this is basically a simple workpiece and tool arrangement. We have analysis. We did the analysis of this kind of diagram many a times in the previous few classes, right? So what is this? This is the atmospheric surface, and this is the machined surface. This is our tool. Okay, this is our tool. Now I will draw few planes and you have to tell me which plane that is. Okay, now let us suppose that this is the axis of the workpiece, or I can say that this is the axis of the machine. Okay. I'm drawing few axes and you have to tell me which axis they are. This is a red plane basically I'm drawing. This plane. Okay, and I am drawing another plane which is like this. Okay, two planes I have drawn. Now you tell me what name can I give to this red plane and what name can I give to this green plane? Comment in the chat box and tell me what should be the name given to the red plane and what should be the name given to the green plane. Both of them are perpendicular. Red is longitudinal plane, which is pi x plane. Very good. And green is, yes, good Santoshi. Green is transverse plane, which is pi y. I will also write transverse. And here pi x is longitudinal. Longitudinal. Okay. Good. Very good. Up to here, it's clear, everyone. Now you see here, can I say that on the side cutting edge, from this portion to this portion, can I say that from this portion to this portion, from this portion to this portion, the edge of the tool is in contact with the workpiece? Say yes or no. The edge of the tool is in contact with the workpiece. Can I say? Yes. 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 Very good. Very good. Very good. I will draw it like this so that you can understand better. Okay. Now, if I am applying a force on the tool in this direction, which is the longitudinal direction, if I'm applying a force, okay, for cutting to take place, I need to move the tool in this direction, right? For cutting to take place, I need to move the tool in this direction. So this is the contact point where there is the contact between the edge of the tool and the workpiece. So don't you think that there will be a contact force, there will be a contact force acting at this point? Don't you think that there will be a contact force acting at this point? Yes or no? Because we are feeding the tool into a rotating workpiece. So definitely at that edge, there will be a contact force which will be acting, right? And here cutting is taking place. At this point, cutting is taking place and the chips are formed. And the chips are forming like this. And the chips are forming like this. So at this point, cutting is also taking place. At that point, cutting is also taking place, right? Cutting is also taking place. So don't you feel that the workpiece is rotating like this? All of you listen carefully. Something is important. The workpiece is rotating like this. The tool is held here. So at this particular point, cutting is taking place. The chips are flowing in this direction. So can I say that in this direction, cutting force is acting? Can I say that in this direction, cutting force is acting? Say yes or no. Yes. Yes. Just observe the diagram. I'm just getting one call. I will just attend that call and I will be back in 1 minute. Yes. Okay. So do you admit that cutting force will act in this direction? Say yes or no. Say yes or no. I want you to respond. Yes. Manikanta, why are you saying no? Manikanta, why are you saying no? See, cutting force. Cutting force means this tool will exert a force on the workpiece and the workpiece will exert a force on the tool. So in this direction only, it will act. Because this entire, you can say that here also one cutting force will act, here also one cutting force will act. You can say like, here also one cutting force will be there, here also one cutting force will be there, here also. But in general, I am representing it with one line. Okay, so the direction in which the cutting force will be acting will be perpendicular to the edge, will be perpendicular to the edge and along the edge. Along the edge it will be. And along the edge it will be. Right? How many of you say yes, or how many of you admit it? How many of you are okay with this? If you have doubt, I will explain you once again. Asha Kiran, are you there in the class? Asha Kiran Sheikh, are you following this? Are you following this? Yes, Sheikh, have you got it? So you tell me one thing, that this is our cutting force and this is our contact force. There are two forces which are there. And this is my longitudinal plane and this is my transverse plane. This is my longitudinal plane and this is my transverse plane. Do you see that any of the forces are acting in any of the plane? Whether this cutting force is acting in any of the plane or this contact force is acting in any of the plane. Do you see any of the forces acting in any of the planes? This is the X plane. This is the Y plane. This is the cutting force. This is the contact force. These two forces are mutually perpendicular to one another. This cutting force is acting along the cutting edge. This is the X. This is the X plane. This is the Y plane. So do you see any of the one force, whether the cutting force or the contact force are acting in any of the plane? Have you got my question? Have you understood my question? Have you understood my question? Say yes or no. నేను ఏమంటున్నానంటే cutting force, contact force, they both are mutually perpendicular. And we have two planes. One is pi x plane and another one is pi y plane. Okay, one is pi x plane, another one is pi y plane. By looking at this diagram, can you tell me that whether the cutting force or the contact force are acting along any one of the plane? Means these two forces, whether they are parallel to any of the plane or not. Can we assume which one is in transverse plane? Santoshi, tell me. Which force is in transverse plane? Cutting force is in transverse plane. So transverse plane is going that side. Transverse plane is going that side. And cutting force is in this direction. So how can you say that it is in the transverse plane? It is not in the transverse plane. I am asking that any of the force is parallel to any of the plane or not. Any of the force is parallel to any of the plane or not. Can I say that this cutting force is parallel to pi x plane? Can I say that? No, I can't, because this pi x plane is going parallel to the axis, but here there is an edge which is inclined at some angle. The side cutting edge is inclined at some angle, na? Are you following the class or not? Say yes or no. Those who are not getting, say I am not getting. Don't be silent. Don't be silent. Yes, Hemant Nayak only responds. What about others? Clear? Janvi, Lakshman Das? Okay. So basically, why I have drawn this diagram is to that in tool references, in machine reference system, we have two planes. One plane is pi x plane, another plane is pi y plane, another plane is reference plane. But actually, when you do the machining, the two forces which are happening, or the two forces which are coming into play, which is the cutting force and the contact force, these two forces are not acting in any of the planes of the machine reference system. Okay, these two planes are not acting in, or these two forces are not taking place in any of the two planes of the machine reference system, neither in the x plane nor in the y plane. Okay, if is it clear to you that this force is not acting in any of the plane, then only you will be able to understand. You clearly see that these two forces are not in any of the plane. See, this cutting force is acting along the side cutting edge. This side cutting edge is not parallel to the X plane. X plane is like this, and side cutting edge is like this, and our cutting force is like this. So the cutting force, we can't say that it is parallel to this X pi X plane. It is not parallel. Similarly, this pi y plane is also not parallel to this contact force is also not parallel to the pi y plane. Okay, so these two forces are not in the planes of pi x and pi y. For that purpose, to do the analysis of the forces, we bring two different planes, and these two different planes are the planes of the tool. Okay, see, what we will do is, we will incorporate two different planes. Okay, one plane will be along the side cutting edge like this. One plane will be along the side cutting edge like this. This is one plane along the side cutting edge, one plane. Okay, and one plane will be perpendicular to the side cutting edge. One plane will be perpendicular to the side cutting edge. One plane will be perpendicular to the side cutting edge like this. Okay, another plane will be perpendicular to the side cutting edge. So when like this is another plane which is perpendicular to the side cutting edge. So now can I say that my cutting force and my contact force both are the part of, or both are passing through, or both are parallel to this maroon color plane and the orange color plane? Can I say that? Say yes or no. Initially, when I have taken the planes of the machine reference system, which are the longitudinal plane and the transverse plane, my forces were not along the plane. They were not parallel to the plane. So I can't do the analysis of the forces by taking into account the machine reference system. So that's why I have taken two arbitrary planes. One plane is along the side cutting edge and another plane is perpendicular to the plane of the side cutting edge. Now, can you see that these two forces, the contact force and the cutting force, are in those two planes? Okay, so for that purpose, we bring into picture one more tool reference system. One more reference system, which is known as a tool reference system. Initially, we have discussed about the machine reference system. But those machine reference system couldn't be used for force analysis because none of the forces are acting along those planes, either longitudinal plane or transverse plane. So for that purpose, we have brought into picture one more type of reference system, which is known as the tool reference system. Okay, so this tool reference system is known as orthogonal rate system. Okay, ORS, orthogonal rate system. Most of you are getting confused, so I will write in one more section. We have discussed about ASA tool signature, right? It was based on which reference system? Machine reference system. It was based upon machine reference system. And now we are discussing another type of tool reference system, which is ORS tool signature. ORS stands for orthogonal rake system. ORS stands for orthogonal rake system. And this orthogonal rake system is based upon tool reference system. This orthogonal rake system is based upon tool reference system. ASA is dependent upon machine reference system. So why do we need to switch from ASA to ORS? Why do we need to switch from ASA to ORS? Means in cutting operation, two forces which are acting, which is the contact force and the cutting force, they are not acting in any of the planes of the ASA tool signature system. So for that purpose, force analysis is not possible in this. Force analysis is not possible. For that purpose, we move on to another reference system where we use the planes which are in the which are made in such a way that the forces are passing through those planes. So it is used for force analysis. So if simply you want to represent the geometry, you can represent it by ASA system. But if you want to go for the force analysis, then that is not possible. Why it is not possible? Because the forces are not acting along any of the planes of ASA. So that's why we go for the ORS tool signature. Okay. Is it clear, everyone? Is it clear? Say yes or no. Up to here, everything is clear. Ganapati, Santoshi, Janvi, Sheikh, Ganapati. Gunapati is different. Hemant Nayak. Okay, Lakshman. Now we will see the ORS tool signature. So can anyone tell me what are the various components of ORS tool signature? What are the various components of ORS tool signature? How many angles we have? Number of angles 6. Number of radius, that is also equals to 1. How 5, Manikantha? We will have 6 angles and we will have 1 nose radius. Everything will be same. Only the name of the angles will be different. Everything will be same. Okay, only the names will be different. So I will be writing various angles of ORS tool signature. Just pay attention. If some tool signature is given to you, like I'm rubbing this. Like 6 degrees, 10 degrees, 7 degree, 4 degree, 9 degree, 75 degree, and 1 mm. No, Manikanta, no. You have got wrong concept. So just listen to this class. Your entire doubts will be cleared. So here the first angle. Here the first angle is known as what? Can anyone tell me? First angle is known as what? Here the first angle is known as inclination angle. Inclination angle. Okay. We represent it by I. The second angle is known as orthogonal rake angle. Second angle is known as orthogonal rake angle, alpha O. Okay. The third angle is known as side relief angle. Side relief angle. The fourth angle is known as end relief angle. End relief angle. This 9 degrees fifth angle is known as end cutting edge angle. End cutting angle. And this last angle is known as what? Can anyone tell me? Can anyone tell me? It is known as approach angle. Or principal cutting edge angle, and it is represented by lambda, and this one is nose radius. This one is nose radius. Nose radius could be taken either in inches or in mm. Okay, not a issue. Now, how to remember this? How to remember this? To remember this, I will tell you one line. You have to remember it. What is that one line is? I alpha naught C lambda S. Lambda n, sorry. I alpha naught C lambda n. Okay. You have to remember this line. I alpha naught C lambda n. I stands for inclination angle. Alpha naught stands for rake angle. S stands for side relief angle. This E stands for end relief angle. This E stands for end cutting edge angle. Lambda stands for approach angle or principal cutting edge angle. And the last N stands for nose radius. Can you remember it? I alpha naught C lambda n. I alpha naught C lambda n. Can you remember it? Tell me. Can you remember it? Today, most of you are very lethargic. Why? Not at all interested. Am I teaching very boring, or you are not interested in the class? Tell me frankly. Tell me frankly. Why such kind of lethargy in the class? Only very few people are responding. What about others? I won't say that you should respond, but at least you should listen, or you should give some response in between. Na? No one is giving any kind of response. What is the problem? Try to understand. This thing is interesting. All these things are important from competitive exam point of view. Okay. So all of you have to follow me very carefully now. I will be drawing our tool. What is this? What is this? What is this? Anyone tell me what is this? This is a tool, right? Single point cutting tool. Now, now, if I draw a plane, now if I draw a plane, which is something like this. I draw a plane which is something like this. I draw a plane which is something like this. What plane it is? Tell me what plane it is. Tell me, yaar, what plane it is. What is this plane? Workpiece will be here. Workpiece will be here. Longitudinal plane, pi x plane. Pi x plane. Very good. Now, if I draw a plane, this, and if I fill it with color, what plane is this? What plane is this? Tell me what plane is this? Pi? Y plane? Very good. Now, very good, very good, very good. Now, if I have a plane like this, which is along the side cutting edge, which is along the side cutting edge. Okay. This plane is a part of, these two planes were the part of machine reference system. Those two planes were part of machine reference system. But this plane which I am drawing now, this plane, this plane, which is the blue color plane, this plane which is along the side cutting edge, this is known as pi c, and it is known as cutting plane. Okay, this is known as pi c and it is cutting plane. Now another plane will be perpendicular to this pi c. Another plane will be perpendicular to this pi c, which will be something like this. Another plane will be perpendicular to this pi c, which is something like this. Okay, this plane is known as pi naught or orthogonal plane. This is known as pi naught and orthogonal plane. This is known as cutting plane. Is it clear to everyone up to this point? Is it clear to everyone up to this point? Say yes or no. Say yes or no. Yes. Okay. Now we have our reference plane as usual. We have our reference plane as usual. As usual, reference plane we have. This is my reference. Okay. Now, reference plane. Okay. Now, I will be measuring angles with respect to these two planes. Basically, if you see the tool signature, only two angles are mostly changing, which is the inclination angle and which is the orthogonal rake angle. Only these two angles are basically changing. This relief angle and cutting edge angle are same, and only this approach angle is changing. Okay, principal cutting edge angle. Only three angles are new. The names of the units with only these three angles are new. All the other angles are same, more or less they are same. So basically, we will try to see that what is the meaning of this inclination angle and what is the meaning of this orthogonal rake angle with the help of this new diagram. Okay. Now you tell me, if I take alpha b back rake angle, with respect to which plane we were measuring that angle and in which plane we were measuring angle, and you tell me what about alpha side with respect to which plane we were measuring that angle and in which plane we were measuring that angle. Can anyone tell me? Can anyone tell me? Can anyone tell me? Can anyone tell me? Repeat the question. Alpha B back rake angle. Back rake angle means the angle which measures the backward inclination of the rake face, and the side rake angle, the angle which will be measuring the sideward inclination of the rake face. So we measured that angle with respect to reference plane, pi r and pi r. And in which plane did we measure it? In which plane did we measure it? In which plane did we measure it? Back rake angle. Pi y plane we measure it. Very good. In pi y plane we measure it. Okay. 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 No, okay, okay. Not pi x, pi y, only pi y measured it. Now all of you listen carefully. For a moment, I am rubbing these two planes. And I'm drawing the pi y plane here. This is my pi y plane or not? This is the pi y plane or not? This is the pi y plane. You want me to show me with darker shade? I will show with darker shade. This one is pi y plane. This one is pi y plane. Yes? Yes? Say yes or no. This one is pi y plane. Yes? Say yes or no. This is pi y plane only, na? If you take it that side, it will be the remaining half of the pi y plane. Now we have measured the back rake angle with respect to pi r, and we have measured it in pi y. So which angle it was actually? Which angle it was? Which angle it was? It was that angle was this angle. That angle was this angle. The angle, this pi y plane will definitely cut the reference plane. The pi y will definitely cut the reference plane. So the angle made here between the rake face and the reference plane in the pi y plane, the angle made by the rake face and the reference plane in the pi y plane, this angle is known as what? Alpha B, alpha back rake angle, alpha back rake angle, alpha back rake angle. Okay, now listen to me once again very carefully. The angle made between the rake face and the reference plane in the pi c plane, this angle, can you see this angle, small angle? That angle is known as I. That angle is known as I. That angle is known as I, which is the inclination angle. So here I can say inclination angle is an angle which is measured with respect to pi r, but it is measured in pi c. How many of you have not understood this? Say in the chat section. How many of you have did understand this? Say yes or no. Everyone got it? Or you want me to repeat it once again? You want me to repeat once again? Say yes. Explain once again. Explain. Very good. Good. I will try to explain it with the help of video. Video as in I will switch on my video. See here. Am I visible? Okay. For example, this is your rake face. Your rake face is having a backward inclination and a sideward inclination. Okay. Your rake face is not like this. It is having a backward inclination as well as it is having a sideward inclination. Two type of inclinations it is having. Now this is your rake face. It is having a backward and a sideward inclination, and this is how the reference plane is kept. This is how the reference plane is kept. Okay, this is the rake face. It is its backward inclination, it is sideward inclination, and this is how the reference plane is kept. Okay, so basically what you are doing, you see in the diagram, the pi y plane, see here, the pi y plane is passing somewhere along this. From in between here, pi y plane is passing like this. The pi y plane is passing somewhere in between. So this is the rake face, this is the backward inclination, sideward inclination, this is the reference plane, and the pi y plane is passing somewhere in between like this. Pi y plane is somewhere in between like this. Pi y plane. So what is the back rake angle? This is the rake face, this is the backward inclination, this is the sideward inclination, this is the reference plane like this. Okay, this is the reference plane like this, and in between somewhere there is the y face. So this angle, the angle between the reference plane and the rake face, will be the back rake angle, Similarly, this is the rake face, this is the backward inclination, this is the sideward inclination, and here it is the reference plane, and here it is the cutting plane. On the edge it is the cutting plane. So this angle is the inclination angle. So what we are saying is the tool is same. There is no difference with the tool is same, right? All the angles of the tool are basically same. There is no change in the angles of the tool also. but the plane on which we are measuring those angles are changed. Reference plane is also same. There is no change in the position of the reference plane, but the plane at which you are measuring the angle, on the plane where you are measuring the angle, Hemant, I got it correct. The plane on which you are measuring the angle, initially you were measuring the angle on the pi y plane. Now you are measuring the angle on the pi c plane. So that's why the magnitude of the angle have changed. That's why the magnitude of the angle have been changed. Initially the angle was more, but since it is having an inclination, the rake face is having two inclinations. That's why you see the inclination angle is smaller than the back rake angle. This inclination angle's magnitude is smaller when compared to the back rake angle. Have you got it? Have you got it? How many of you have not got it? How many of you want me to repeat it once again? Have you understood the difference between inclination angle and the back rake angle? Both of them are same. The only difference is the plane on which you are measuring. Have you got it? Have you got it? Others also comment, please. Have you got it? This is very, very important concept. Yes, sir. Understood. Okay. Everyone have to comment. Everyone have to comment. Those who are listening. Yes. Yes. Very good. Now listen carefully. Okay. Very good, Praveen. If you are getting it, it means that you guys are really intelligent, because this is a kind of topic which I generally don't teach. I leave such kind of topics because it is very difficult for students to understand. If they won't understand, they will say the teacher is not good. So that's why I generally skip these topics. Straight away, I will tell the signature and I will leave. But why I'm telling means we have time and I want you to get the real feel of the subject. Now we will discuss about the side rake angle. So side rake angle we measure in pi r plane and we measure with respect to pi x plane. We measure with respect to pi x plane. So where is the pi x plane? Where is the pi x plane? So pi x plane will pass somewhere around here. Okay. Pi x plane will pass somewhere around like this. Yes or no? Pi x plane will pass where? Pi x plane will be passing somewhere. This is the pi y plane. So perpendicular to this pi y plane, pi x plane will be passing. So something like this pi x plane will be passing. This is my pi x plane. Okay. Okay. This is my pi x plane. Now you see that what will be the side rake angle? The side rake angle is the angle made in the pi x plane between the reference plane and the rake face. Okay. So I will draw it clearly. Take it as the this is the pi x plane. Okay. This is the pi x plane. And here the reference plane the lines are became very, very thick. This is my pi y plane. Okay. This is the reference plane. And this is my pi x plane. Okay. This is the pi x plane. This is the pi x plane. So here you'll tell me where will be the back side rake angle. Side rake angle will be somewhere. Side rake angle will be somewhere here. Right? Side rake angle will be somewhere here. That will be alpha s. Similarly, back rake angle will be here. This one is back rake angle. Sorry, orthogonal rake angle. Sorry, orthogonal rake alpha O. Okay, so this is the sideward inclination, that is alpha s, which is the side rake angle. and here this is the orthogonal rectangle. Orthogonal rectangle. Okay. So the orthogonal rectangle we are measuring in orthogonal plane. So due to the backward inclination of the rake face, so this orthogonal rectangle will look bigger. This orthogonal rectangle will look bigger, but the tool is same. The reference plane is also same. But since the orthogonal plane is at some distance, it is at different location, and we are measuring that angle in orthogonal plane, that's why the magnitude will look more when compared to the side rake angle. When compared to the side rake angle. So the orthogonal rake angle is an angle which we measure with respect to the reference plane, and we measure it in the orthogonal plane. Okay. The remaining angles are more or less they are same. So have you got it? Have you got it? Say yes or no. Can you tell me the difference between the back rake angle, side rake angle, inclination angle, and the orthogonal rake angle? Can you tell? Can you tell? Say yes or no. Say yes or no. Shall I draw this one separately? Okay. I will draw one more diagram. So this is our tool. Okay. So let us draw the X plane. X plane means longitudinal plane. So longitudinal plane will be something like this. Okay. Okay. Now orthogonal plane. This is my orthogonal plane. This is the orthogonal. I'm not drawing the lines because it will create more confusion. This is the reference plane. Okay. This is the reference plane. Now you see the angle made by the rake face, the sideward inclination of the rake face with the reference plane in x plane. In this plane, if you see, with the reference plane, the angle, okay, how much it will be? Let us say the reference plane is here, okay? So this will be the angle. But here, that angle will be this one or this one. Okay, so this is the angle. This is the sideward inclination. So what angle it is? What angle it is? Wait, just wait a minute. I will draw the reference plane. Okay, see here, Hemant. This angle and this angle. Both the angles are measured with respect to reference plane. This angle will be alpha orthogonal. This angle will be alpha side. Okay, so the magnitude of alpha orthogonal will be more because of the sideward inclination of the rake face, and since this orthogonal plane is situated at backside of this pi x plane, so that's why the magnitude of pi naught will look as if it is more when compared to the pi s. So both are measured with respect to the reference plane. Okay, so this is the pi x plane and this is the pi o plane. Is it clear now, or more repetition is required? Is it clear now? Say yes or no. Say yes or no. You want break? 5 minutes break. I've been taking 2 hours now. So you want 5 minutes break, or shall I continue or leave early? Choice is yours. You will say, sir, we are in break only, sir. We are not at all listening to your class. We are just relaxing. The leave early. Okay. Okay. So in between, we have been studying for 1 hour. So let us discuss something other than the topic. I will ask you one question, but the promise you have to make is that you will not Google it. You should not Google it. Okay. Because if you Google it, you will get the answer. You most probably might get the answer. But in general, I want to check your knowledge. Knowledge as in how you relate things with engineering. How many of you have air conditioners in your home? How many of you have air conditioners at your home? You have. Which company air conditioner you have? Samsung. Okay. Others? Most of you in Vizag, they have air conditioners. So I just want you to respond and tell me that how many of you have air conditioners. Say something. Yes, no, something. Yes, sir, Samsung. Everyone is having Samsung air conditioners. Okay. In air conditioner, if you are using a split air conditioner, you will have an indoor unit and you will have a which unit? Another unit is what unit? Outdoor unit. Indoor unit and outdoor unit. So this is the room. Outdoor unit is outside the room. Indoor unit is inside the room. Indoor unit. This is Hemant Nayak, let us suppose. Okay. Hemant. So this AC, you have two tubes which are coming from the outdoor unit into the indoor unit. Okay. Two tubes are coming from the outdoor unit into the indoor unit. Tell me the material of the tube. Very good. Copper. Why do we know this? Because whenever we ask AC technician to keep the outdoor unit in the terrace, he will say that, sir, 800 rupees per meter will be the cost of the copper tube. So costly. 800 rupees per meter is the cost of the copper tube, sir. Not aluminum. Not aluminum, Satvik. You check 110%. 110% I'm sure that it is the tube which is made of copper, not aluminum. Okay. My question to you is, why do we use copper? My question to you is, why do we use copper? Tell me. Don't Google it. Think and tell me. I will give you 1 minute of time. Each and everyone in the class can give their own answers. See, this is not subject. This is something which is general knowledge, I would say. Tejasvi, you are saying high thermal conductivity. If the tube which is carrying cold refrigerant from the outdoor unit to the indoor unit, if it is having high thermal conductivity, then don't you think that its cooling will be lost to the environment? It is having high thermal conductivity, so it will lose all its cooling to the outside environment. So in the indoor unit, the cooling of the refrigerant will be less. So is it a profit or a loss? Is it a required or unwanted aspect? If the thermal conductivity of copper is more, then what will happen? Specific heat cover, it has insulating cover. So if it is having insulating cover, then why should I use copper? Why can't I use steel? Why can't I use aluminum? Why can't I use brass, bronze? Many other metals are available. Why can't I use them? I can use any inferior material and I can protect it with insulation. Why is it necessary to use copper only? Why is it important to use only copper? Low thermal diffusivity. What does it mean? Less corrosive. See, other metals are also less corrosive. Stainless steel I use. Na? Stainless steel watches, we wear stainless steel watch. Na? Stainless steel కూడా corrosion అవ్వదు. థర్మల్ కండక్టివిటీ, థర్మల్ డిఫ్యూజివిటీ ఏవేవో చెప్తున్నారు కానీ కరెక్ట్ ఆన్సర్ ఎవరు చెప్పట్లేదు. No one is giving me the right answer. The right answer is, all of you listen carefully. You want me to give the answers or you want to give more try? It does not lose or gain heat easily. No, not a correct answer. Tejasvi is not giving satisfactory answers. It can maintain the cooling effect. Cheaper. It is 800 rupees meter. It is not cheaper. It is very costly. Copper is very costly. Okay, you give up? Do you give up on the question? Shall I give the answer or you want to try more? You give up? Madhav? Take much time, sir. No, answer. Okay, answer. copper is the only metal, okay, which does not lose its ductility at low temperatures. Okay, so copper is the only metal which does not lose its ductility property at low temperature. All the other metals loses its ductility property. So what will happen if you give a sudden jerk to the tube, other metal tube? What will happen? It will being brittle. It will break. It will being brittle. It will break. So the copper is the only metal which will not lose its ductility at low temperatures, right? All the other metals, they will become brittle. And if they become brittle, what will happen? చిన్న షాక్ తగిలినా, చిన్న జర్క్ ఇచ్చిన, చేత్తో కొంచెం కొట్టినా మీరు ట్యూబ్ని, ఆ ట్యూబ్ బెండ్ అవ్వదు, మధ్యకి టక్ మని రేపోద్దు, ప్లాస్టిక్ లాగా. చాలా మంది చాలా ఆన్సర్స్ చెప్పారు నాకు. థర్మల్ డిఫ్యూజివిటీ, థర్మల్ స్పెసిఫిక్ హీట్, అంటే థర్మోడైనమిక్స్ లోని హీట్ ట్రాన్స్ఫర్ లోని చదివిన పదాలన్నీ వాడేశారు. ఏదో ఒకటి కరెక్ట్ అవుదా, ఏదో ఒకటి కరెక్ట్ ఆన్సర్ రాదా, గుర్తుంచుకోండి. ఓకే, సో లెట్స్ కంటిన్యూ. So this is the workpiece. This is the atmospheric surface. This is the machine surface. Okay, and here is the tool. Okay, now if you cut it with orthogonal plane, if you cut the tool with orthogonal plane is something like this, right? This is our orthogonal plane. This is my orthogonal plane. This is my orthogonal plane. Okay. This is the orthogonal. So if you cut the tool with this orthogonal plane, what will happen? Will you be able to see this machined surface? Tell me. Means orthogonal plane means this entire plane will cut this much of part. Okay, so this is the plane through which I am cutting it. So will you be able to see in the sectional view, means with the cut view, the sectional view, will you be able to see the machined surface? Will you be able to see the machined surface? Say yes or no. Will you be able to see the machine surface? Hmm? Yes or no? You will be seeing something like this. You will be seeing something like this. This is the tool. Okay. This is the reference plane. These are the chips. This is the workpiece. Okay. This is the uncut chip thickness. This part is known as uncut chip thickness. This is the chip thickness because this is the cutting chips which are flowing. This is the chip thickness. And what angle is this one? Tell me. What angle is this one? Okay. You tell me what is this angle? You tell me what is this angle? Tell me what is that angle? I have cut the tool with the reference plane at this point, with the orthogonal plane. So definitely I will not be able to see this machine surface in a confingery. What I will be able to see is only this much part. Okay, only this much part I will be able to see. Only this much part I will be able to see. Right? So that's what I have drawn here. That's what I have drawn here. Now you tell me what is this angle and what is this angle? What is this angle and what is this angle? This angle will be alpha naught, which is the orthogonal rake angle. Why? Because I have cut it with respect to the orthogonal plane. So definitely when I will look it from this direction, I will see this alpha. Oh, very good, Manikanta. And what is this angle? This is the side relief angle. That is the side relief angle. This angle is the alpha gamma s. Is it clear to everyone? 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 Say yes or no. Very good. Now, the angle of the tool, this angle, it is known as theta, which is wedge angle. Okay, wedge angle or lip angle. So this angle theta is the wedge angle or lip angle. Now just give me last 10 minutes. I will explain one concept and then you can leave. Diploma students, can you tell me what I'm trying to draw? Hmm? This is my workpiece. This is the uncut chip thickness, uncut chip thickness, uncut chip thickness. This is the workpiece. This is the workpiece. So this is the tool, this is the tool, and this is the tool. So here you see this angle is alpha naught. As you all know, this is alpha naught angle. This angle is gamma s angle. And this angle is theta angle, which is the wedge angle. Okay. So now you see, what am I doing is, I am reducing the alpha naught. So in this particular case, I have made alpha naught 0. So wedge angle have what? What happened to wedge angle? Theta have increased or decreased? Theta have increased or decreased? Alpha naught is 0. Increase, very good. Here I have further reduced the rake angle. Means initially my alpha naught was below the reference line, which I consider as positive. Now I have furthermore increased the wedge angle theta. So my alpha naught have become negative in this case. So I will say that this is the positive rake tool, 0 degree rake tool, and this is the negative rake tool. Okay. So we have basically three type of tools in which the rake angle is positive rake angle, another rake angle in which the rake angle is 0, and the third type of rake angle in which the rake angle is negative. Okay, three type of rake. So what I can basically say is, the wedge angle is inversely proportional to the wedge angle is inversely proportional to the rake angle, which is alpha naught. The wedge angle is inversely proportional to the rake angle. The wedge angle is directly proportional to you have to tell me that you see this diagram. Here the thickness of the tool is so less. Here the thickness of the tool is somewhat more. Here the thickness of the tool is very, very high. You see the thickness of the tool. This is the complete tool. Na? The red portion is all tool. So you tell me in which, in case number 1, case number 2, case number 3, in which case the strength of the tool will be highest. Tell me in which case the strength of the tool will be highest. Strength of the tool, strength, third one. Na? So that's why when you increase the wedge angle, it is directly proportional to the strength of the tool. Okay, with the increase in wedge angle, strength of the tool will increase. Okay. Now, wedge angle is inversely proportional to, you will see this diagram once again. You tell me which tool is more sharp, this tool, the third one, second one, or the first one. The sharpness of the tool is more in which case? First one. Very good. Others, are you getting? Nayak, Janvi, everyone is getting? Very good. So I can say wedge angle is inversely proportional to the sharpness of the tool. Okay. So basically we have three type of configurations. Whenever we machine soft and ductile materials, we go for positive rake tool. We go for positive rake tool. Whenever we manufacture hard and brittle materials, since those materials are very, very hard and they are brittle, since those materials are very, very hard and they are brittle, they will impose much force on the tool. So that's why we require the strength of the tool to be more. In that case, we use a negative rake tool. Okay. And whenever we do intermittent cuttings, means continuously we are not machining. Whenever we do intermittent cuttings, then we will go for the negative rake, zero rake tool. Okay. So for soft and ductile materials, we require positive rake tool. For intermittent cutting, we go for zero rake tool. And for hard and brittle materials, we will go for a negative rake tool. Okay. So here I am drawing one more small diagram. Just we are done. We are just done. This is the tool, and this is the reference line. This is alpha naught. This is what? Gamma s, and this is what? Theta, which is wedge angle. So alpha naught plus theta plus gamma s is equals to 90 degrees. So have you understood the relationship, the various relationships I have established here, that what kind of tool we use in which kind of configuration? Positive rake tool, negative rake tool, and zero rake tool. For ductile materials, we'll go for soft and ductile materials will go for positive rake, in which the wedge angle is less, the strength of the tool is less, but the sharpness is more. We will go for zero rake tool. For intermittent cutting, means continuously not cutting, in between if you are going for cutting, then you will go for intermittent cutting, zero rake tool. And for hard and brittle materials, we'll go for a negative rake tool. Okay. Is it clear up to here, everyone? Shall we stop here? Have you understood the session? Have you enjoyed the session? Yes. Okay. Good. Okay. I will take the attendance. Wait. 47 students are present. Thank you. Email you. Thank you.